we see?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, tell me one more thing. I am drawing a line. Whether you can see that line?
No, sir. No,
I
sir.
have,
No,
I
sir.
have.
No, sir.
No, sir.
Okay. I have drawn a line, but I'm not sure why it is not coming. Okay. Some duplicacy problem is there. So, but without the line, it won't be much. Won't be of much use. Okay. And presentation you could see, right?
Yes, sir.
Yes, sir. Yes.
Yes, sir.
Yes, sir.
And if I draw a line that you can't see. Okay, just let me do this. I put pen and okay, let it be. Now can you see the line or not?
Yes, sir.
Yes, yes, we can.
Oh,
Yes.
oh, fantastic.
Yes, sir. Yes,
Almost
sir.
gave up. Okay, fine. Okay, so today we'll start with the welding portion. And as I've told you, I'll be discussing about welding mainly, and some part of forming also I'll discuss. But that we'll see later. How much forming I have to cover. Maybe I have to cover all of it, but we'll decide it later. First of all, we'll do the welding portion first. Okay, so the first chapter of welding, not so much of a chapter. If you look at the syllabus is not that much precisely defined. But for our purpose, we will define it very precisely. We'll talk about definition of the welding. Then we'll talk about the requirements of an ideal weld. So whenever I say welding, what is meant by that? What do I mean from a welding operation? So what are the 4 requirements so that a particular operation can be called as a welding operation? That we'll see, right? Then we'll talk briefly about SMAW. SMAW is the most common form of welding. We'll see that there are so many variants of welding which are available in the market, in the industry, right? But out of that, the SMAW process, shielded metal arc welding, is also called as SMAW. So SMAW process is the most common form of welding process. So most of you, if you have seen any welding going on in and around your place or by the roadside or in any hardware shop, whatever welding they do, most of it is SMAW. Few of it will be gas welding. These two are the most common form of welding, which are very commonly seen. Of course, there are other specialized forms of welding, but they are not so much common that anybody could see that, right? But I'm very sure all of you or most of you could have seen SMAW or gas welding at some point of time. We'll discuss what is meant by these things, right? Then we'll talk about the classification of welding processes. So you should remember this is not an exhaustive classification. I'm not going to cover all the welding processes that are available. As I told you previously also, no? Welding University of Texas, they have a 4-year BTech program in welding. So it is that much of a vast field. But we won't be covering all that. We'll cover most of it, right? So the classification of welding processes, I will cover most of it. And the classification is based on the type of energy and based on the filler wire. How this classification is made, that we'll discuss, right? And then for this chapter, finally, we will talk about the types of weld joints, weld positions, and the type of weld bead geometry. So what is meant by weld bead geometry? How do we define it? What are the features of a weld bead geometry? Everything we'll see one by one. Okay, so today we'll start with the definition first. So whenever I say welding, so the first thing which you people will realize, or which the first thing which comes to your mind, that welding is a joining process, right? So the next question is, if welding is a joining process, how does it differ from other joining processes? So the common answer is welding is a joining process, but it is a permanent joining process. So when I say permanent joining process, that basically means that if you want to break that joint, you have to damage the part. That is meant by permanent joint. When I say permanent joint, theoretically, the joint cannot be broken. But practically, any joint, anything can be broken or cut off. That is not a very big issue, right? But the point is, a thing will be called as a permanent joint if, in order to break it, in order to damage that joint, or in order to remove that joint, you have to damage the part also, right? So welding is a permanent joining process. The definition which is shown over here, this is the definition given by the ASTM, American Society for Testing of Materials. This is ASTM definition. Also, American Society of Welding, ASW, they also follow this definition, right? That welding is the localized coalescence of metals. Here they have mentioned metals because when welding was defined, that was long back. Of course, nowadays we know that welding is not only about joining of metals. Welding can join non-metals also. Welding can join two plastics also. Welding can join a metal and a plastic. Of course, welding can join metal and metal. That is well known, right? So welding is first and foremost, it is a localized coalescence of metals. In place of metals, you can write materials also, right? Materials is the more correct word, but you can write metals, that will not be wrong also. Okay, so welding is a localized coalescence wherein the coalescence is achieved by heating to a suitable temperature. So this statement says that in case of welding, in case of any welding process, there is a heating mechanism involved. We have to have the heating in somewhere, right? Either we can have the heat from a flame, that is called as gas welding, or we can have the heat from an electric arc, that is called as electric arc welding, right? We can have heat from the electric resistance. We know that resistive heating is the I square RT heating, right? So that will be called as a resistance welding, and so many other classifications are there, right? While talking about the classification, we'll talk about these things, right? So coalescence is achieved by heating to a suitable temperature. This suitable temperature, most commonly, this is the melting temperature. When I say suitable temperature, suitable is not a very technical word, it is an English word, right? So heating to, most commonly, it is a melting temperature. Some variants are there. When we talk about solid state welding, we'll talk about it later, where the heating does not need to occur till melting point, right? Where the welding can be done without melting also. Those are a different class of processes. That's why they have used the word suitable here, right? Heating to a suitable temperature, whatever is the requirement. If we were talking about electric arc welding, so it will be melting temperature. But if we are talking about friction stir welding, so that time the temperature won't be melting temperature. It will be something below that, right? With or without the application of pressure, and with or without the use of a filler material. So pressure means whatever parts are being joined, if you are applying pressure also on the faying surfaces, on the parts which are being joined, right? Then that is with application of pressure. And if you are using any external material, so that is called as a filler material. So either you can use a filler material, or you cannot use, or you should not use a filler material. So it is up to you. So the most generalized form of definition for welding is a localized coalescence of materials wherein the coalescence is achieved by heating to a suitable temperature, with or without the application of pressure, with or without the use of filler material, right? So the idea behind welding is, when you are doing a particular welding process, suppose you have a part A and you have a part B, and if you are joining these two parts, after the joining, suppose after the welding process, it is becoming one common part, right? A plus B was being joined and it has become part C after joining. Maybe this will be the welding area. This is the welding portion where welding has occurred. So the idea behind welding is, welding will be considered as a good welding if after joining this part A and part B, after the welding process, it should behave as one, right? It should behave as a single part. After the welding, we should not be able to distinguish that this was part A, this was part B, and this has been joined. It should behave, it should appear as a single part only. Also, if you do the tensile testing and if you apply some loads on it, the welding joint should not fail. Even though the part may fail somewhere else. The welding joint will still be okay, right? So welding will be considered as a good welding if after the joining process, whatever parts you are joining, part A and part B, after the joining, it should behave as one. And second thing, whenever you are applying the load, the failure of the part, the failure of the particular component, it should happen at any location other than the welding portion. If the welding portion is failing, welding portion will fail if the welding is not proper. So if the welding portion is failing, then definitely something wrong has been done. You are not able to do the welding properly, right? And if after application of load, the welding is okay, some other portion is failing, then we'll say that this was a very good welding process, right? So these are some examples. So here we have some MS plates, MS pieces. MS means mild steel pieces, right? So here you can see these are two MS pieces. This is part one, this is part two. So after joining, you can see the weld bead has been deposited like this, right? So there are so many spattering has taken place, so many blowholes are there. Here you can observe some undercutting also, that material is not able to fill the gaps properly, right? Lack of penetration is there. So this is an example of bad weld, right? MS mild steel by itself, it is a very good candidate for welding. If you want to do welding processes, if you want to practice welding, you should always start with MS, because MS is a very good, it has a very good weldability. It can be very easily welded. But even then, the person who was doing it, he could not do it properly. And this is an example of a bad weld, right? So next image, here we have SS pieces. SS means stainless steel pieces. So many pieces are there, and here the joint has been made. So here you can see SS is a very difficult to weld component, right? Welding stainless steel is very difficult because stainless steel is not thermally conductive. So whatever heat you are giving, it is not dissipated and it distorts the part. So it is a difficult thing to do welding of stainless steel. But even then, the person who was doing it, he could do it very properly. You can see that even though you can distinguish that here the welding joint is there, but still you can see that some sort of continuity is there, right? And in such type of welding, if you apply the load, definitely the part will not fail from the welding portion. It will fail from somewhere else, right? So this is example of a good welding. This is some other picture which I could find, right? So this is a welding of pipes. So welding of plates and welding of pipes, these are the two most common application of welding, right? In case of industrial applications, when you talk about industrial welding processes, most of the time we are concerned with joining two plates or joining of the pipes, right? So for different type of pipe materials, for different type of pipe dimensions, we use different type of welding processes. So we'll get to that later. So this is just to show you that here we have one pipe, vertical pipe, and here we have the horizontal pipe. And the person who is doing the welding, he has done the welding here. Of course, you can see that again, this is not a very good welding. The welding which he has done, some cracks you can observe here. So in such conditions, if you apply the load, the welding will fail. So this is not a very good type of welding. Okay. So the basic scheme of welding, whenever we talk about the welding, I told you, whenever I say welding, most of the times you will refer to the roadside welding. So roadside welding, also called as SMAW welding, it is an example of a arc welding process. Okay. So maybe I'll write SMAW. Okay. So what happens is, in case of SMAW, we have a plate like this. Okay. And you have another plate like this. Okay. So suppose this is plate A, this is plate B. Okay. So plates A and B, these are called as workpieces. These are called as workpieces, also called as base plates. Okay. Workpieces or base plates, right? The surfaces where the welding has to be done. Suppose I want to make a butt joint over here, lap joint, butt joint, I will discuss later also, and you may be knowing also. You could have, last class you told, no, you have done some welding in the labs. So you may be knowing also. So if I want to make a butt joint, the surfaces which are to be joined means for plate A, this is the surface, and for plate B, this is the surface. So the surfaces which are to be joined, they are called as faying surfaces. So throughout the course, whenever I say faying surfaces, you should realize I am talking about those surfaces which will be joined through the welding process, right? So this is a faying surface. In case of SMAW, we have a electrode holder. This you could have seen. And in the electrode holder, we fix the electrode and it is connected to some power supply. And the base plate is also connected to a power supply. Whether it is connected to positive terminal or negative terminal, that we'll also see later. There is a concept called as straight polarity and reverse polarity. We'll understand that. So I don't want to confuse you right now. So this is the schematic of this process. So you have the welding, this is electrode holder. This is called as electrode holder. And this is the electrode, right? So what happens is you switch on the power supply, an arc is formed due to the heat of the arc. These faying surfaces, they melt and they mix with each other. And when you move the electrode throughout the joint, suppose you start from here, so initially arc will be formed over here, it will melt the plate A and plate B, it will melt the faying surfaces, and then next instant you will move in this direction. So as you move away from the starting point, the temperature will again fall down. So the portions of plate A and plate B which got melted, they will mix with each other and then they will solidify and ultimately will end up with a joint. So this is the basic scheme of welding, right? So also sometimes what can happen is you are making an arc with your electrode and your base plate. With the arc, you can use a filler metal also. This also you can hold in another hand and you can bring it inside the arc. So what happens is sometimes if the plate thicknesses are very large, then just forming an arc and melting the faying surfaces are not enough, right? You are not able to fill the joint properly. That time, if you want to deposit more material, then you can introduce a filler wire. So these are the basic components of any welding process. These are the basic components of any arc welding. But most of the times, in most of the welding processes, these things are common, right? We will have a workpiece, we have electrode, we have filler material, and we have power supply, right? These things are common in most of the welding processes. Maybe from this diagram it will be much more clearer, right? So here is the base plate or the workpiece or the base metal which on which we are doing the welding. So this schematic you can refer to your first year. In your first year you could have seen you could have done the welding process in the lab, right? So you could have faced a similar scenario there. So there is a work table on which the workpiece or the base metal is kept, right? We have the electrode holder inside which the electrode is fixed. Electrode holder and the base plate, it is connected to the power supply. Power supply is connected to the power source, obviously, right? And other things, these are the lead cables and so many other things. So this is the basic schematic of SMAW process, right? SMAW stands for shielded metal arc welding. So it is called as a shielded metal arc because the electrode is a metal wire and the metal wire is covered with some kind of coating. We'll discuss about these things later. The purpose of showing this slide to you is just to enable you to visualize that welding looks like this, right? And these are the basic components of the welding process. Okay, now we'll talk about the requirements of an ideal weld. So ideal weld means the welding which is satisfying all the required criteria for the process. So requirement of an ideal weld, there are basically four requirements as per the definition of the ASTM or definition by the American Welding Society. And most of the experts, almost all the experts, they agree that in order to qualify, in order for a process to qualify as a welding process, it should have these four features, right? So the first feature which any welding process, any ideal welding process should have, that it should have some sort of energy introduction. Energy in some form should be supplied, right? So in case of arc welding process, the energy will be obtained from the electric arc. In case of gas welding process, heat energy will be obtained from the flame, right? In case of resistance welding process, it will be from the resistive heating and so on, right? So any welding process, whether it is a fusion welding process, arc welding process, resistance welding process, solid state welding process, any welding process, it should have introduction of energy in some form. We have to provide some sort of energy. Without providing the energy, you cannot carry out the process, right? Also here in this slide, I have given a distinction between fusion and melting, right? So fusion means the parts are being melted and they are getting joined also. So in case of welding, we'll use the term fusion. Fusion means the faying surfaces. If you recall the diagram which I draw, the faying surfaces of part A and part B, they are melting and later they will be getting joined also. So that thing we can call it as a fusion welding, right? When I say melting, melting means the parts are just melting, right? Later they won't be, afterwards they won't be joining, right? So in case of welding, we can use the term fusing, that part A and part B will be fused together. I should not say part A and part B will be melting together. That is an incomplete statement. Either I should say part A and part B will be melting together and then they will be solidifying together, or I should say part A and part B will be fusing together. Okay. So from now onwards, whenever I say fusing or fusion welding, you should realize that I am saying the parts will be melting and later they will be joining also, right? This is a common question asked in interviews also. If you tell the interviewer that yes, I know welding, so he may ask, tell me the difference between fusion and melting. So you should say, sir, fusion means the parts are being melted and later they will be joined also. So fusion is the combined statement. Melting is a simple thing. Melting means parts will just be melted. Later they may get joined or may not get joined. We are not concerned about that, right? In case of welding, we should use the term fusing. But in case of casting, if some of you take the advanced foundry techniques course, right? So there I'll be discussing about casting. So in case of casting, we use the term melting. In case of casting, never use the term fusion because nothing is being joined over there. Okay. So the first requirement of welding is energy should be provided. Second thing, the cleaning. So any process will be called as a welding process if the parts which are being joined are being cleaned first. So the cleaning can be through chemical action. Most commonly, we use a chemical called as acetone or isopropyl alcohol. Cleaning can be through sputtering of an arc, right? Or it can be through mechanical means like scrubbing. So mechanical cleaning is the cheapest and the most simplest form of cleaning which is available. And this sputtering cleaning is the most sophisticated, right? So if you're dealing with some highly complicated part, highly reactive part, for example, if you're dealing with titanium, right? So titanium, very easily it forms oxide layer. So titanium you have to clean through sputtering first. After you clean the titanium, then you should do the welding process. So the characteristic of an ideal welding is the parts which are being joined, it should be cleaned first, right? The type of contamination.
Sputtering?
Sorry?
So what is the meaning of sputtering of an arc?
Sputtering of an arc means sputtering is basically a momentum transfer phenomenon. Sputtering is a momentum transfer phenomenon. I will tell what it means. Suppose you have your surface like this. This is your, suppose aluminum plate is there, right? So aluminum has a tendency that if you put aluminum in open air, aluminum tends to form a layer of oxides on it. So aluminum, on top of aluminum, we have a layer of aluminum oxide, alumina, Al2O3. So if you try to do welding of this, it won't be a very good welding. You are doing welding for aluminum, you are using the process parameters and the electrodes for aluminum, but basically you are starting with alumina layer. So of course the process will go wrong. So what we do, we take this thing, we put it in front of an arc. Sputtering of an arc means we generate a very low voltage arc, right? So inside the arc, we have some ionized gases. We'll discuss about it later. How do we get ionized gases? So what happens is these ionized gases, they will impinge on this alumina layer, and due to the momentum transfer phenomena, they will remove this alumina molecules or alumina atoms from top of the aluminium. It will remove the, depending upon the thickness of the alumina, we will control the voltage of the electric arc, we'll control the sputtering duration also, and then we can remove the alumina layer. This is the most sophisticated form of cleaning action. Of course, you should remember when I say it is the most sophisticated form, it means that once you have cleaned it through sputtering action, you should do the welding also, right? You should not take it out from the sputtering chamber, then again the oxide layer will form. That's why I'm saying this is a very complicated thing, very costly thing also. When in the same vacuum chamber, whenever you are cleaning it through sputtering, inside the same chamber, you should do the welding also, right? Most of the times, if you are cleaning through sputtering, we are doing the welding through electron beam. We call it as electron beam welding, which is to be carried out inside a vacuum, right? So sputtering is basically a momentum transfer phenomena. sputtering means cleaning through momentum transfer. This is called as sputtering. Okay, so contaminant types. The contamination may be in the form of organic films. It can be in the form of adsorbed gases. It can be some chemical compounds, generally an oxide layer. If it is a chemical compound, generally it is a oxide layer. So I told you chemical cleaning, most of the times acetone, isopropyl alcohol, these things we use. These are very commonly available things, very cheaply available also, right? If you are doing mechanical scrubbing, then we can use wire brush. This you could have seen in your lab work, right? The wire brush can be used along with the hand drill also, right? So you can use this for cleaning smaller portion, not very big parts, right? So this is one figure which is showing the difference of an aluminium plate before cleaning and after cleaning. So before cleaning, aluminium is looking like this. Some aluminum oxide layers are over there, and this has been cleaned. This has been cleaned mechanically only. So you can see the lines over here, the lines of that mechanical scrubbing, right? So after cleaning, it is looking like this. So if you are doing it for a very non-critical application, suppose you're doing it for a particular lab work, you are doing it for just to creation of a joint. That time you need not bother about it, right? You can clean it using your manual methods, and then you can do the welding. Maybe you can do the GMAW welding or GTAW welding, whatever you want, right? Of course, some layer of oxide may still form, but it won't be that much detrimental layer, right? And it won't have that much effect on the final product. But if you are using it for a critical application, suppose you are using titanium and you want to weld titanium for spacecraft application, there you should not take any chance. There you should do the cleaning in a vacuum and do the welding in a vacuum, and then everything is fine afterwards, right? So first thing, the second thing in case of a welding is the part should be cleaned. The third thing in case of a welding process is the way to exclude the atmosphere. Any welding process, it should have an inherent feature that during sorry, कोई कुछ बोल रहा है क्या यार? Any question is there or what? Okay. So the third thing in case of welding is a way to exclude the atmosphere. That even after the cleaning, during the welding also the part may get contaminated, right? If you are doing welding, if you are doing the welding not inside a vacuum, if you are doing it in open air, then the part may get contaminated, right? Uh, Either some contamination in the form of gases or contamination in the form of dirt or slag, something may come up, right? So any ideal welding process must have a way to exclude the atmosphere, right? That once the part has been cleaned, it should remain clean, right? So a welding process will be considered as an ideal welding process if it has an inherent mechanism or a way to prevent this from happening. Prevent this means contamination, a way to prevent contamination from happening. So it can be through flux or it can be through gas shielding. Flux means whatever flux are being used, it will dissociate and form a gas. So either you can get the gas from the flux or you can directly use the gas, right? So this is the first example in case of SMAW. This is an SMAW, right? So when we'll talk about SMAW, that time we'll discuss about this. That in case of SMAW, we have a electrode coating. So one of the function of the coating is to generate gas. The coating, it generates the gas. It generates the gas, right? And that gas forms a layer around the weld zone and it prevents the contamination. So this is one way to do it. I told you there are two methods, right? Either you use a flux which will generate the gas. So in case of electrode, in case of SMAW, the electrode coating was the flux which were generating the gas, or you can directly use the shielding gas. So directly using shielding gas, the common processes are GMAW or GTAW. When we'll talk about GMAW and GTAW, we'll talk that shielding gases, how do we apply the shielding gas, what are the effects of the shielding gas. So what happens is arc is formed between the electrode and the base metal, but the arc is surrounded through a inflow of the shielding gas. Shielding gases may be argon, it may be helium. Sometimes it is a mixture of argon and helium also, right? It forms a shielding layer which prevents the contamination. right? So this is just an example which I wanted to show you. This is taken from a research paper, that in practicality what it looks like, the shielding environment, what does it looks like, right? So here you can see an arc has been formed between the electrode wire and the base plate, and a shielding has been provided. Maybe argon gas has been provided and it is shielding. Here you can also see it is forming a sort of covering vortex layer, it is forming around it, right? And the last thing, requirement of an ideal weld, it should be metallurgically satisfactory. Metallurgically satisfactory means the weld which has been deposited, it should have a controlled composition. Ideally, the composition of the weld should be exactly same as that of the base metal. If you recall the first slide which we saw today, in which we talked about the definition of the ideal welding, I told you, that there should be no difference between the welded part. Part A and part B, after the welding, it should behave as a single part, right? So metallurgically, there should not be any difference between the parts which are being welded and the joint which has been formed. So ideally, the metallurgically, there should not be any difference. But practically, of course, it cannot be achieved 100%, right? But we try to go as close to it as possible, right? What happens is, if you are doing the welding process correctly, if you are using the correct parameters, and if you are using the correct methodology to do the welding, most of the times the welding region performs better than the base metal. I told you, the welding region will not fail. Even if you apply the load, the failure will take place from somewhere else. The welded joint will not fail. So thing is, sometimes the welding region is more than satisfactory. It has better metallurgical properties compared to the base metal, right? So again, if we come back to this, so here you can see the first requirement of welding process was energy. So here energy is taken from the electric power supply, which is converted into an electric arc, and the heat from the arc is used for the welding process, right? First requirement was energy. Second requirement was cleaning of the surfaces. So of course, if you recall, while doing the welding, you cleaned the surfaces first, maybe using a wire brush or using acetone chemical or isopropyl alcohol chemical. You could have cleaned the surfaces. So second requirement was fulfilled. Third requirement is a way to exclude the atmosphere. If you recall, while doing the welding, lot of gases were generated, right? The lab in charge or the person who were helping you, maybe the teaching assistant, he could have told you that lots of gases will be generated. You should take care against it, right? You should not inhale those gases. So those gases were generated from the flux, and those gases were doing the shielding. It was shielding the welding arc so that contamination is not there. And the last thing is the metallurgically satisfactory. So metallurgically satisfactory, it will be metallurgically satisfactory if you are using the correct electrode material, and if you are doing the welding process correctly. If you are using the correct voltage, correct current, if you are using the right welding speed, right standoff distance. What are these things we'll discuss later also, right? If you are using the correct parameters, then you can have the fourth one also. So ideally, if the welding process is an ideal welding process, all these four things should be present simultaneously. Then we can say that the welding process is an ideal process. So before we stop for today, I want to start the classification of the welding. So the first one is as per the source of energy, right? This we have talked so many times during today's lecture. So I think we can cover it today, right? So if the source of energy is flame, right? If the energy is obtained from a flame, then it is called as oxyacetylene welding or oxy welding, right? These full forms you should remember, and I hope throughout the course you will remember it yourself. You don't have to memorize it. Just O for oxygen, A for acetylene welding. When you do gas welding, you will remember it by heart. No, won't be a problem. So as per source of energy, there are four sources of energy through which welding can be done. Either it can be done energy from the flame, that is oxyacetylene welding or oxy welding, or energy can be obtained from the electric arc. So it is shielded metal arc welding, gas metal arc welding, gas tungsten arc welding, submerged arc welding, electroslag welding, electro gas welding, plasma arc welding, atomic hydrogen welding, and flux core arc welding, right? I understand that I am saying these names continuously and you may be finding it very difficult to remember, But don't worry, I will be giving the full forms of this to you. And I hope that at the end of the course, you will also be able to tell these names very quickly without any hesitation, right? Third classification, third source of energy, electric resistance welding. It can be spot welding, seam welding, projection welding, flash butt welding, and upset welding. We'll talk about these things. And lastly, we have the radiant energy. Radiant energy can be electron beam, ultrasonic, or laser beam welding, right? So in this slide, whichever portions have been made bold, like oxy welding, electroslag, electrogas welding, plasma arc welding, similarly electron beam, ultrasonic, laser beam, these things we won't be covering, right? And the portion which are written without making it bold, oxyacetylene welding, SMAW, GMAW, GTAW, SAW, spot, seam, projection, flash, upset welding, these things we'll be covering in class, right? So first classification is as per source of energy. We have 4 sources of energy, and this is the classification. Next one is as per use of filler material, but this we'll discuss on Monday. We'll discuss in next class. This is the first lecture which we are having, and we are having it online. So I'm sure you people may have some doubts, and you can ask the doubts now. If you have any questions, any queries, or any comments to make, you can ask now. Yeah.
Sir,
Go ahead.
can you explain that metallurgical satisfactory ones?
Metallurgically satisfactory means ideally after the welding, the uh, part A and part B, after the welding, there should not be any difference. Means there should not be any metallurgical discontinuity between part A and part B and the welding joint. So this is part A, this is part B, and this is the welding joint, right? So if you perform metallurgical studies in part A, and if you perform metallurgical studies in part B, and if you perform metallurgical studies in the welding joint, there should not be any difference between these 3 points. Ideally, it should be like this. Of course, practically it is not possible, and also we have a case for dissimilar welding. So there it is theoretically also not possible. But since these definitions are quite old, and most of the welding processes, they satisfy these definitions. So when I say metallurgically satisfactory means there should not be any metallurgical differences between part A, part B, and the welding joint. This is what is meant by it.
So how is it protected from contamination during the gas welding process?
During the gas welding, sir, if you see, I told you there are 2 methods by which the contamination can be prevented. Suppose I am talking about the oxidation problem. So oxidation will occur only if the oxygen is able to enter the metal zone, and then it is able to combine with the metal, and then it will form the oxide. Similarly, if the nitrogen is able to enter, then only it will form the nitrides. But if we generate a shielding environment, if we generate this type of environment where if we generate this shielding environment where the gas covering has been made, now the atmospheric oxygen or nitrogen cannot enter the weld zone. So if they cannot enter, then they cannot form oxides or nitrides. If they cannot form oxides or nitrides, then they cannot contaminate, right? So shielding is the third step, sir, if you remember. First, in the second step, in the cleaning step, we have removed the contaminations, and then we are shielding it.
How shielding is made to prevent the contamination?
How shielding is made means थोड़ा विस्तार में पूछो, थोड़ा और elaborate करो इसको. Shielding made मतलब क्या हुआ? समझा नहीं मैं.
No, sir, he is asking that the gases that are formed must not react.
How it is formed? Okay. समझ में आ गया. देखो, SMAW welding में क्या होता है? In SMAW welding, we have a metal wire. This is a cross section of the SMAW welding only. We have this metal wire. We have this metal wire, right? And the metal wire is provided with a coating. So if you remember, in case of in case of a lab work, you could have seen electrodes are looking like this. It has a metallic end, and then it has a ceramic sort of coating on top of it, flux sort of coating, right? So when the arc is struck between the base metal and the tip of the metal wire, so the heat of the arc, it melts the base metal. That is well known, right? That you can realize at this point of time. It melts the base metal as well as it melts the electrode wire also. But the heat of the arc, it also dissociates this flux. So the gas forming agents, normally CaCO3 we put inside the flux material. We put this calcium carbonate. So due to the heat of the arc, this calcium carbonate dissociates into calcium and carbon dioxide. This carbon dioxide gases are released and they form this covering. I am saying covering, but you should not think that it is going and covering that weld zone. It is spreading out in all directions. So it is preventing the atmosphere from entering there, or it is pushing out the atmosphere from that region. And that's how it is preventing the contamination.
Okay, sir. Thank you.
Okay. Anyone else?
No, sir.
Sir, will you send us the full forms of the terms which you told just a few minutes ago? That this will be covered in
Right.
this semester.
I will be sending it, but I will be sending it at the end of this course. And before it, I won't be asking in any exam also. So don't worry about that. My idea is after this, after you do this course, no, after you read about these welding processes, you won't need me to send these full forms. So let's wait for that. Let me do this course. Let me explain the subject, and let you people also just listen to it, just read about it. And I don't think you will need these things. You will need the full form later. You will be able to do it yourself only. Right? You will be able to remember it. We will discuss it so much now. You will be able to work out the full form yourself. If not, then at the end of the course, I'll send you also. This is not a big thing. Right? Okay. Anyone else?
Sir, do you suggest any books for this course?
Yeah, for
Yes, sir.
welding.
Yes, sir.
Yeah. Maybe I'll write it in the MS team. From there, everyone can refer. I forgot to put it in the slides. In case of welding, there are few. I can mention the writers. There is a book by O.P. Khanna, which is called as Welding Technology, and there is a book by P.N. Rao, which is Manufacturing Technology 1. There are 2 volumes, Manufacturing Technology 1 and 2. So one of them is for machining, one of them is for welding, casting, forming. So manufacturing technology 1 you can follow P.N. Rao, and then there is book by R.S. Parmar. Again R.S. Parmar, Welding Technology Volume 1. Right, R.S. Parmar also has written 2 volumes. First one is for welding technology, second one is for welding metallurgy. Welding Technology Volume 1. Okay, so I have written it in the MS team. From there, you people can refer, and you can refer these books. Yeah.
Can we follow Ghosh Malik book means manufacturing science?
Ghosh and Malik Manufacturing Science, of course, you can follow, and you can you will get the basic idea of the welding over there. But the thing is, Ghosh and Malik is too much of research oriented. So if you're reading welding for the first time, I will say don't read from Ghosh and Malik. Maybe later, if you do advanced welding course, which I take for 7th semester. So if you do that, that time I will ask you to follow Ghosh and Malik. Don't read it. Don't read welding for the first time from Ghosh and Malik. Read it from O.P. Khanna, R.S. Parmar, P.N. Rao. These are good books to start with. Also, you can
Sir,
follow.
among these,
Yeah.
sir, among these 3, which is the best?
Best in what sense?
Like
Sir, for competitive
point and point,
exams.
point to point. Yes, sir. Both
Point to
competitive
point,
and
O.P. Khanna.
Means
O.P. Khanna is best. Yeah. O.P. Khanna and R.S. Parmar. These are very good books. And maybe the order is O.P. Khanna is the best one, then R.S. Parmar, then P.N. Rao. But the useful things like the concepts, very nice concepts, you will find in P.N. Rao also. P.N. Rao is a Tata McGraw-Hill publishing house. So this is a very weird question for me. Which book is good and in which way? Maybe you can start with O.P. Khanna. There you will find everything which I will be teaching. Even R.S. Parmar or P.N. Rao, also you will find everything which I am teaching. Another book which I want to mention here is Degarmo Black and Kosher, which is again manufacturing technology or manufacturing technology only. So it has all the manufacturing thing. It has machining, welding, casting, forming, everything, and even some portion of metallurgy also. That also you can follow. It is a very, very nice book. But my suggestion is you start with OP Khanna and RS Parmar. You can use either one of them. Both are very good book for starting. And then when you have a basic knowledge, then you should move forward. Then you should move forward to better books. Okay, anyone else? Anyone else? Any more doubts? No?
Like, do you have the PDF, like any one of the books?
Sadly, I don't have. I have the books with me, so I don't need the PDFs for them.
Sir, actually, we are not in like hostel, so
I know, I know.
Yes, sir. And if you have the soft copy, then you can send the link.
Ma'am, I don't have the soft copy or the PDFs. Sorry. I have the books with me. We'll see what can be done. We'll see. For the time being, today is the first lecture. PPT also you could have seen. You don't need to do any homework for it. If nothing works out, then maybe I'll scan the books and then I'll send you the chapter materials from there. Right. And let's see. Let's hope that in the middle of the semester, you people are called in the hostel. That will be really great, right? So if nothing works out, I'll make sure that you get the material in one way or the other. I'll try to do that. Okay. Anything else?
No, sir. Thank you.
पीएन राव कैसा है कॉम्पिटिटिव के लिए?
कॉम्पिटिटिव के लिए यार पीएन राव कॉम्पिटिटिव कॉन्सेप्ट्स वाइज ठीक है, कॉन्सेप्ट क्लियर हो जाएगा पीएन राव पढ़ के, लेकिन कॉम्पिटिटिव एग्जाम्स के लिए कॉम्पिटिटिव एग्जाम्स वाला बुक ज्यादा अच्छा है. मेड इजी का एक बुक आता है प्रोडक्शन टेक्नोलॉजी, रिटन बाय कोई एक है बंदा है, मैं नाम भूल गया उसका. उसका किताब सबसे अच्छा है. उसमें क्या है कि प्रीवियस ईयर्स के गेट वेट इन सब के क्वेश्चंस रहते हैं और कॉन्सेप्ट्स भी रहता है. तो कॉम्पिटिटिव एग्जाम्स पॉइंट ऑफ व्यू से यार ये थ्योरेटिकल बुक्स को मत करो, लेकिन ये है कि हाँ अगर पढ़ लोगे पीएन राव वगैरह अच्छे से, पीएन राव, ओपी खन्ना, आरएस परमार, डिगार्मो, ये सब अगर पढ़ लोगे तो कॉम्पिटिटिव एग्जाम्स के क्वेश्चंस हो जाएंगे आराम से. लेकिन अगर सिर्फ कॉम्पिटिटिव एग्जाम पॉइंट ऑफ व्यू से सोच रहे हो फिर तो कॉन्सेप्चुअल बुक्स ना ही पढ़ो तो ज्यादा अच्छा है. मेरा सजेशन ये है कि अभी सेकेंड ईयर में हो तो अभी से मत करो कि कॉम्पिटिटिव एग्जाम्स का सोच रहा हूँ मैं. फॉलो दिस बुक्स, रीड अबाउट इट. once the concepts are clear, no, then you don't need then you won't need to follow those books a lot. What I did, no, I did not read competitive exams books. I just read the conceptual books. Competitive exams का मैंने क्वेश्चन पेपर्स किए थे प्रीवियस ईयर्स के, हो गए थे आराम से. कोई बाहर से तो कुछ पूछता नहीं ना, अपने क्वेश्चन थोड़ी बनाते हैं. कॉन्सेप्ट क्लियर होगा तो सारा कुछ कर दोगे क्लियर उसमें. ठीक है. और बोलो कुछ.
And sir, which means for the electric arc welding, which processes do means क्या बोलते हैं सबसे ज्यादा यूज होता है, वो SMW है और कुछ और सर ऐसे.
सर इलेक्ट्रिक आर्क वेल्डिंग अगर सबसे ज्यादा यूज का बात बोलोगे तो SMW होता है, ठीक है. लेकिन वेल्डिंग का जब कोर्स पूरा पढ़ लोगे आप लोग, तब आपको ये समझ में आएगा कि वेल्डिंग के केस में किसी भी क्वेश्चन का आंसर एकदम ब्लैक एंड व्हाइट नहीं है. अगर तुम जैसे बोलोगे ना सबसे ज्यादा क्या यूज होता है, तो अगर मैं ये देखूं कि सबसे कॉमन क्या है वो SMW है. लेकिन अगर मैं इंडस्ट्रियल पॉइंट ऑफ व्यू से देखूं सबसे कॉमन क्या है वो GMAW है, ठीक है. सिमिलरली एल्यूमिनियम वेल्डिंग करने के लिए सबसे कॉमन क्या है वो GTAW है. सो हर एक क्वेश्चन का ऐसा सीधा आंसर नहीं है, तो वो हर क्वेश्चन में डिपेंड करता है. वेल्डिंग एक ऐसा है ना कि वेल्डिंग में हम कर कुछ भी सकते हैं, लेकिन थ्योरेटिकली कोई दिक्कत नहीं है. प्रॉब्लम है कि वो कर पाना मुश्किल है. इसका एक मैंने एनालॉजी सोचा था समझाने के लिए. सपोज अगर तुम वेल्डिंग में सही पैरामीटर्स फॉलो कर रहे हो, पर्टिकुलर वेल्डिंग प्रोसेस को फॉलो कर रहे हो, पर्टिकुलर मटेरियल के लिए जो सजेस्टेड है, जो गाइडलाइंस है तुम उसको फॉलो कर रहे हो, then it will be like you are playing cricket with a football and the person who is bowling does not know how to bowl, and you are having a very big bat and you are scoring runs very easily. It will be like that. But if you're not doing it, if you're not following the guidelines, if you are using different parameters, then it will be like you are playing with a hockey stick. and the person who is bowling is Dale Steyn, and he is using a golf ball, and if you miss, you are out, right? So theoretically, it is not impossible to play Dale Steyn bowling a golf ball using a hockey stick. It is theoretically not impossible, but practically very, very, very difficult. And chances are that things will go wrong. वेल्डिंग में ऐसा ही सिनेरियो है. वेल्डिंग में कोई चीज ऐसा नहीं है कि नहीं कर सकते. ऐसा कोई नहीं बोलेगा कि नहीं कर ही नहीं सकते. ऐसा नहीं होगा. बहुत ही कम केसेस हैं, स्पेसिफिक केसेस हैं, मैं बताऊंगा उनके बारे में. लेकिन बहुत ही कम ऐसा होगा कि सीधा बोलते नहीं हो ही नहीं सकता. जाओ, हो कुछ भी सकता है, करना बहुत मुश्किल होगा. हम जो वेल्डिंग जो पढ़ रहे हैं, हम लोग जो हम पढ़ेंगे, आप लोग जो पढ़ोगे, पॉइंट यही है कि ये समझ पाना कि किस चीज के लिए कौन सा प्रोसेस यूज करना है. करने को तो कुछ भी कर दो, गाइडलाइंस अवेलेबल है, उनको बस फॉलो करना है आपको, ठीक है. लेकिन ये देखना है कि किस चीज के लिए, जैसे एल्यूमिनियम के लिए हमको GTAW करना है कि GMAW करना है. यू शुड एटलीस्ट नो दैट, देन यू कैन फाइंड आउट द कोड्स कि ठीक है, GMAW के लिए कौन सा गैस, कितना फ्लो रेट, कितना करंट, कितना स्पीड एंड सो ऑन, राइट. So to answer your question, there are different aspects of सबसे ज्यादा यूज. ये जो टर्म है ना, सबसे ज्यादा क्या होता है, ये थोड़ा कॉन्वोल्यूटेड टर्म है. तो अगर तुम वॉल्यूम की बात करोगे तो SMAW, बट डिफरेंट मटेरियल्स के लिए डिफरेंट वेल्डिंग प्रोसेसेस हैं. उनके लिए अलग, मतलब एल्यूमिनियम के लिए कभी SMAW यूज करते ही नहीं है. तो ऑब्वियसली एल्यूमिनियम वेल्डिंग की अगर बात करेंगे तो एल्यूमिनियम वेल्डिंग इंडस्ट्री में सबसे ज्यादा जो यूज होता है मे बी GMAW और GTAW, डिपेंडिंग अपॉन द थिकनेस एंड सो ऑन, राइट. बहुत ज्यादा कंफ्यूजिंग तो नहीं लग रहा ना सर ये वेल्डिंग का जो सब्जेक्ट है? बताओ, थोड़ा आइडिया दो मेरे को, ओपिनियन दो अपना.
बिल्कुल नहीं,
No,
बहुत
sir.
ही अच्छा लग रहा है.
Thank you,
No,
sir.
sir.
ठीक, अभी आज तो पहला क्लास है, इसलिए हो सकता है उतना ज्यादा ना चमक रहा हो, उतना मतलब चमकना मतलब समझ में ना आ रहा हो उतना, लेकिन होपफुली आएगा समझ में. कहीं पे कोई प्रॉब्लम हो तो मेरे को तुरंत बोल दो कि सर ये चीज क्या बोल रहे हो, मेरे को हमको नहीं आ रहा समझ में. हमको मतलब मेरे को नहीं आ रहा समझ में, बाकियों को आ रहा है तो हम क्या करें, ठीक है. किसी को भी नहीं आ रहा समझ में तो बोलो मेरे को, आई विल ट्राई टू एक्सप्लेन इट बेटर. आज का चीज तो कुछ था नहीं, थ्योरी था, बड़ा सिंपल था. आगे जाके चीजें थोड़ी थोड़ी कॉम्प्लेक्स होंगी. दैट टाइम आई विल नीड योर हेल्प टू एबल टू एक्सप्लेन इट प्रॉपरली, राइट. एक मूवी थी ना टॉम क्रूज की, जिसमें वो बोलता है हेल्प मी हेल्प यू, भूल गया नाम उसका. स्पोर्ट्स एजेंट बनता है वो, कोई बेसबॉल प्लेयर का नाम भूल गया उसका, जो भी है. सो हेल्प मी हेल्प यू, यू शुड हेल्प मी टू हेल्प यू, राइट. With this movie trivia, we'll stop here. If no more doubts are there. कोई डाउट है किसी को?
No, sir.
No, sir.
ओके, फैंटास्टिक. चलो ठीक है, फिर खत्म करते हैं आज का. मंडे का लेक्चर का लिंक मैं भेजता हूँ मंडे को, ठीक है. चलो, टेक केयर,
Thank you, sir.
ओके.
और सर बुक्स एक बार MS Teams में लिख देना.